Hi, welcome to a video on the chain rule. We're going to talk about the chain rule, which is a rule for finding derivatives of functions that are compositions of two or more functions. So what we mean by that is if the function you're trying to take the derivative of has essentially a function inside of another function, then we have to use this rule to do the derivative of it. So as an example, you can see this first one here, f of x. You have this 5x minus 3, which is a linear function inside of an exponential, so a power. So you have a function 5x minus 3 inside of like an x to the 6th function. Now we have the same sort of thing in the second example. We have this quadratic, this 6x squared plus 3x, that's inside of a square root function. So an x to the 1/2 power, if you'd like. So these are examples of functions that if we want to take the derivative, we would need the chain rule. In the last example, we have this log of 8x squared minus 3x. So you have this quadratic function here that's inside of a log function. So again, three good examples of when you would need this chain rule. So what's the chain rule says? So the chain rule is saying if you have a function inside of another function, so what we had in these three examples, then the way you get that derivative, and the easiest way for me is to remember it in words, is you take the derivative of the outside. So you take the derivative of the outer function, and then you're going to multiply that by the derivative of the stuff that's inside. Okay, so the derivative of the outside multiplied by the derivative of the inside. So again, this part here is the inside, derivative of the inside, and this first part here, which we'll highlight in red, that's your derivative of the outside function. Alright, so we're going to do some examples, and hopefully those will help to clear this idea up. So again, for me, when I do problems, I'm going to refer to this as doing the derivative of the outside times the derivative of the inside. So let's first take the first example that we have up there. We're going to look for the derivative of this function f of x equals 5x minus 3 to the 6th power. Okay, so the outside function is that power function. So when we start doing our derivative, our f prime, we're going to start with using the power rule. So the power rule says take this exponent, this 6, and bring it to the front. Now when we do this, we leave the inside alone, so you don't touch 5x minus 3. That just stays there. But when I do the power rule, I bring the power to the front, and then I lower it by 1, so that becomes to the 5th. So this part right here, this is my derivative of the outside. Now I'm going to times that by taking the derivative of the inside. Now the inside function is the 5x minus 3. So the derivative of 5x minus 3 is just 5. Derivative of 5x is 5, and the derivative of the minus 3, 0. So we have our derivative of the outside highlighted in red times the derivative of the inside. That's the chain rule. Now we can just go one more step on simplifying our answer here. The 6 and the 5, these two monomials can be put together, so we can make that a 30. And then we have times 5x minus 3 to the 5th. So this is my derivative of the function. That's an example of the chain rule. Okay, so you'll probably feel better if we do another example. So let's try another one. Let's try that second one that had the square root on it. So we had a function f of x that was 10 times the square root of the 6x squared plus 3x. Now that function, before I do the derivative of it, like any function with a square root or a radical, I like to write that with an exponent. So I'm going to change this to 10 times 6x squared plus 3x to the power of 1/2. So now really when I get the derivative of this, when I go to find my f prime, it's very similar to the previous problem. I have an inside function, which is the 6x squared plus 3x, and the outside function is the exponent. Now the 10 in the front is just a coefficient. That's just going to stay there. So my derivative is going to be a 10, which is just going to stay there, times, and then I apply my chain rule. So the chain rule being derivative of the outside, so I'm going to do a power rule. 1/2 comes to the front. Again, remember, when you do the derivative of the outside, the inner part just stays the same. So 1/2 to the front, lower 1/2 by 1 gives me -1/2. So this part right here is my derivative of my outside. All right, I'm going to times that multiplied by the derivative of the inner. So 6x squared plus 3x has a derivative of, let's see, 2 times 6, 12x, plus the derivative of 3x, which is 3. That is my derivative of the inside. Okay, so there's your derivative. Now we can make this look a lot nicer if we do a little bit of cleaning up, but as far as the chain rule, I'm finished. I'm going to go one more step, do a little algebra for you. For example, like the 10 times 1/2. 10 times 1/2 is just 5. Let's make that a nice 5 right there, combining these two. A negative exponent, I'm going to want to flip that to the bottom. I'll do that in the next step here. Well, actually, let's just do that now. Let's just flip that underneath. Now, this is all one expression here. This is all being multiplied together. So it's just one, basically one big term. So when I flip that to the bottom, it just goes to the bottom of everything. That means a positive power. And then I still have the 12x plus 3 on the top. So I combine 10 times 1/2 for 5. I keep my 12x plus 3 there. And on the bottom, I flipped my negative exponent below. Alright, so let's just keep going here and just make it look a little cleaner. Usually we like to write those fraction exponents back in their radical form, so I'm going to put this back as a radical. 6x squared plus 3x on the bottom. Now on the top, we could distribute the 5. Usually we don't like to distribute. Usually we like things in factored form. So you know what I'm going to do? I'm actually going to factor the 12x plus 3 and take a 3 out of that. And let's just write this in a completely factored form here. So I pulled out the 3 from the 12, and I pulled out the 3 from the 3. So now, here's how I'm going to write my answer. And again, answers can vary, all up to you, how far you want to go, how much you want to do of factoring, and basically, you know, how the directions from your teacher are given. How do they want their answer written? But this would be a nice form of the answer here. So here's my derivative. I used the chain rule, and then I just did a bunch of algebra to clean it up. All right, thank you. I hope this has been helpful.